Hi there. Today we are going to talk about the PostgreSQL network filter for envoy proxy. I'm Fabrízio. I'm working in IT for 25 years. I'm a Postgres developer at Postgres. It's a company that provides professional services on Postgres and develop related tools. My friend Álvaro will talk more about Postgres so very soon. I'm a PostgreSQL contributor and a Brazilian community leader.
Okay, hello everybody. I'm Álvaro. I'm the founder of Postgres. This company means on Postgres. We do work on R&D on Postgres. We provide professional services. That's part of the background. And I'm frequently found on Postgres conference, on other database, or even Java programming conference sometimes. And I also like to work on the Postgres community. And in general, I also founded a Postgres nonprofit, the foundation in Spain, Fundación PostgreSQL, which is devoted to promote Postgres all around the world. Also just compulsory curriculum. I'm also on Amazon Data Hero. And you can find me on Twitter or my personal website for any question after this talk. So let's talk about today about how we could enhance what is Postgres observability. Let's try to analyze where it comes from, how it works, and if there's anything we can do to make it better. So basically, Postgres monitoring. Because we'll keep logs and traces for potentially other talks. Let's focus on monitoring. And Postgres monitoring is something that is actually not a solution that is integrated in core. You normally need to use external tools to make queries to Postgres and to get some information. The good news is that Postgres provides quite a good wealth of information that you can query with SQL. So what is called the Postgres catalog, which includes tables and views, which you can query, provide a lot of information related to how the database is operating. So this is very good for information, and we can make queries to gather all this monitoring data. The problem is that the volume of queries that we need to sometimes incur with Postgres for getting all this monitoring information may or may not be that small. Especially if, let's say that we're doing a multi-tenant database where we have a lot of databases, we might want all these databases to be monitored independently. And that means that basically we may need to multiply all the queries for monitoring across all the databases. They may lead to hundreds or even thousands of queries per monitoring cycle. Then if we want to like a fine-grained resolution, like 1 second, then we're imposing some not negligible load on the database. Also, sometimes to monitor, we need to install additional extensions like pgstat statements or pgstat monitor. These extensions require a restart of the database, and restart means downtime. This is sometimes not even acceptable on many environments. And they also may require separate configuration or external binaries, agents. So this leads to complexity. So is there any way in which we can do this better? So let's think about how the Postgres protocol works, what is called the front-end, back-end protocol. This Postgres protocol is a layer 7 TCP protocol. This means that it's not operating at the TCP layer, it's application layer. It's very well documented, which is an advantage. You can see here a drawing of what is a sequence of potential messages that flows from client to server to perform a query. This protocol is very well structured. There's no kind of catch-all or generic message for many things, like, for example, MongoDB protocol, which basically everything is run command, and you wrap almost everything right now under it. A specific message for very specific actions. There's dozens of different messages, and they're all very specific and very well defined. This makes it easy to decode and understand the protocol very well. And it's also very stable. The current version, called version 3, has been operating since Postgres 7.4, which is circa 2003. So it's been 18 years running with the same protocol with no changes. And this protocol is very widespread. It's obviously implemented in all drivers and all tools that access Postgres. And not only is used by Postgres, it's also used by other databases that have settled on using the Postgres write protocol to enhance compatibility with, again, tools and drivers. They don't need to write their own, and they have just implemented the Postgres protocol. Databases like Yugabyte or CockroachDB, Crate.io, or even the most recent Noise Page, an experimental project from the Mello University, all these implemented Postgres protocol, obviously also Postgres derivatives, they also benefit from this protocol. So what if we could, by studying this protocol, by inferring some data from this protocol, we could provide observability to Postgres? This would benefit this whole ecosystem at once. So let's look at this, how the protocol works, what is the architecture? Well, it's pretty simple, right? We have a client, we have a Postgres server, and they connect, and then the message flows that connects between them is the Postgres wire protocol, this front-end, back-end protocol that I was mentioning before. Now, what if we would intercept this protocol, set up a middle box, a middleware layer, where we may intercept this protocol and proxy it? So in this case, what we would be looking at is an intermediate layer here between this Postgres client and the Postgres server, where the protocol is intercepted and forwarded exactly the same as it came before. So basically, a proxy. Now, if this proxy just passes the TCP protocol, there will be no change. This is totally transparent to the client. But if we use this proxy, this decoder box, to actually obtain metrics from this traffic and send them to an external location for storing and visualizing and processing all these metrics, then we've got observability basically for free. We're just decoding the protocol transparently to the server. So to summarize, the advantages of exposing this observability to obtain these metrics via this process of proxying the traffic and decoding it are basically that we're replacing a pool model we're replacing a pool model where the monitoring agent is going to be querying the database to push model. As soon as we've got metrics, we'll push them out, and we'll have basically real time for these metrics and less overhead. But especially on the database side, there's zero impact. It is 100% transparent, and this means that there's no performance impact whatsoever, and there's also no configuration required, there's no restarts required, there's no agents, there's no restarts, no downtime. So this is very beneficial for the database. It's a zero impact measure on the database. Obviously, this can also, on certain environments such as Kubernetes, this can be deployed as a sidecar. We can even inject on some instances a sidecar and then transparently proxy the traffic and transparently provide all these metrics without disrupting at all the existing clients and servers. The side effect of this is that because this has zero impact, we may leverage this to actually increase the volume of metrics we are providing. Sometimes we need to control, putting on a DBA, Postgres DBA hot. Sometimes we can need to put a limit and say, no, we cannot get all these metrics or this volume or this resolution because we're going to overwhelm the database and we cannot disrupt the traffic. However, if we're providing this observability at this proxy layer, we can actually, as long as we don't obviously saturate the proxy either, but this will be impact-free for the database. So we can increase the volume of metrics or the resolution that we're capturing in these metrics. And obviously, this also opens the door to new functionality that will be discussed at the end of the talk as future research and future opportunities for leveraging this layer.
So, for this functionality that Álvaro mentioned, the proxy box, let's introduce Envoy Proxy. Envoy Proxy is a high-performance C++ distributed proxy designed to single services and applications. And it was built by learnings of solutions such as Nginx, HA Proxy, hardware load balances, and cloud load balances. And Envoy runs alongside every application and abstracts the network by providing common features in a platform-agnostic manner. It's a middleware. Envoy Proxy is a middle between Postgres, between a client application and a server application, as we can see here on this slide. And the power of Envoy, the extensibility, we have the ability to have a TCP proxy. So to connect the client to Postgres, Envoy just needs an extension, a TCP proxy filter, to make to create a connection, a TCP level connection between the application and the server, your application and the PostgreSQL. And the application takes advantage of Envoy's extensive backend features. So on Envoy we have load balancing, health checking, outlier detection, and so on. And also the statistics are produced, but are grossed at TCP level. For example, number of TCP connections, number of bytes passed over TCP session, number of connection errors, and so on. Access logs also limited by TCP sessions. And the connection model for PostgreSQL is the same, because the extensibility of Envoy, we have the ability to change filters. It means we can create a pipeline of extension, a pipeline of filters to do something over the TCP connection. And the PostgreSQL filter introduced in Envoy understand the PostgreSQL wire protocol. Or, it understands the bits and bytes, the communication from client to server at the TCP7 layer, the TCP protocol, to expose some metrics and do some tests over the TCP connections. And also, the architecture is so extensible that we can produce some metadata about the traffic passing over the TCP connection using PostgreSQL filter. We use a small SQL parser to parse the SQL messages from client to server and produce some metadata to pass over to another filter, maybe to RBAC, or wholly based access control, to grant or revoke some usage of some objects, like this user can use this table, can write in this table, and so on. And this is another feature introduced in this network filter for Envoy proxy. So how it all started? It's to make the history, the long history short. Actually, if you see on the issues on the Envoy development and on the issues on GitHub, we all have other issues related to why we don't have a network filter for PostgreSQL yet. And in November 2019, Álvaro created an issue with a complete background context and why we need this and how we will have more information, how we can improve the observability over PostgreSQL connections. So we did an effort, a really community effort, because we had contributions from several companies like Tetrity, from Envoy maintainers, of course, from Congress. We did a lot of work to make this happen. And the first POC we sent to community some time ago. In next slide, we will see the timeline. In a really short time, we got this measure to core. And now we have the ability to expose metrics about PostgreSQL connections without a pooling mode on Postgres backend, like Álvaro said. So it led to 10 issues and new features being implemented in several other areas. And of course, we need help. If someone wants to help us to improve more and more the network filter and other areas are involved to join us. And this is a small timeline on November 9, 2019. This issue was created. The first POC about network filter was on January 2020. On July 2020, we have the first version on release 1.15. After that, on last October, we had release 1.16 and was released the filter metadata, the ability to produce metadata from Postgres filter. And we have a very important case here that Álvaro will talk more later. Last release was 1.17, released this month, in January. We released on Envoy the Start TLS transported socket feature. This is very important to have a feature called SSL termination to a next version. We hope we can finish it to next version that will be released on next March. But this is the plan. And about the metrics that currently are being supported. We group the metrics, those metrics are counters, I mean metrics per second, and we have errors, messages, statements, sessions, transactions, and we drill down the counters, for example, the numbers of inserts, statements, the number of updating statements, delete statements, other statements, and so on. So I will do a quick demo soon, and we will see this running. And let's switch to demo. Here I have 4 consoles. On the top left, I have a PSQL console. I mean a PostgreSQL console. Here I have the ability to run several statements over PostgreSQL server. On the top right, I'm doing a tail on PostgreSQL log just for statements. It's to see that we are not doing any pooling on Postgres side to grab metrics, to expose metrics. On bottom left, I have a debug log for Envoy proxy, when we can see the decoder working, decoding messages for connection. And on the bottom right, we have all the metrics exposed by PostgreSQL network filter, for Envoy Postgres network filter for sure. Let's, for example, create a small table and see what happens on the filters perspective here. Just to have some space. Let's create a table called customer with 2 columns. Here on Envoy connection, Envoy logs, we can see the statements that front end, I mean the client send to server, and the response of server, of backend to client. And the metrics, we have sessions, how many sessions, encrypted or unencrypted, how many messages was sent from backend to front end, from front end to backend. In Postgres terminology, the front end means the client, and the backend means the server, just to clarify. And here on the statements, we can see we executed one statement and one statement other, because the drill down statements we recognize delete, insert, select, and update. Okay, and there are some parse error or parser. Here I disable the parser because the currently SQL parser embedded on Envoy is very, very poor, and I'm not using here to avoid some confusion. And let's see other statement, an insert, for example. It's the same on PostgreSQL. We don't have any pooling, grabbing metrics. Here we increase statements. Now the specific counter for insert was increased. The messages, the flow messages from client to server get logged here. Of course, this is it's a debug level. Please don't do this in production. We will produce a very large logs. Don't do that. And the select, it's the same. And all the messages are decoded, all the commands and the response, messages from client to server and from server to client. And here we have a select increase. So this is a very powerful feature because open the doors for a lot of incredible ways to improve the observability. This is just the beginning. I will switch back to the slides. And this is an example. There are on GitHub a repository. There are some Docker Compose with several containers to have a complete example of usage of this network filter, of course with Prometheus and Grafana, and here is the expected result of all the things that we talked until now. Here we have some examples for transactions per second, back reads and writes, front end and back end messages, number of statements, drilling down to insert, select, update, all DML operations, and of course number of sessions per second.
All right, so this is what is available right now. Just go download Envoy 1.17. That's the latest version. You'll be able to use all this. Now let's look a little bit into the future. What is coming on Envoy 1.18, the next version, which is due on March this year. So what we are trying to achieve for Postgres filter for this version is to be able to consider supporting Postgres SSL. Let me tell you briefly about Postgres SSL. First of all, this is not the classical TLS you're thinking of. Postgres SSL doesn't operate at level 4 of the OC layer, but rather at application level. So it's basically similar to what SMTPS does. It's basically you start with an unencrypted connection, a request to upgrade the connection to SSL is performed, and then you switch to encrypted connection, similar to Start TLS. So that's why this functionality will be leveraged, the Start TLS functionality that was implemented on purpose with Envoy 1.17. Now, what is about SSL? SSL is obviously very desirable and a requirement in many environments, but SSL database connections are high. In general, connections are high, right? The SSL and connections to a database are high. And on top of these, SSL and SSL data connections are quite high, right? So the obvious solution is, no problem, we use a connection pooler. What is the most used connection pooler? One of the best connection poolers in Postgres, PG Bouncer. But PG Bouncer is single-threaded. And so establishing SSL connections, even via PG Bouncer, that is expensive. And you can actually separate it, bring totally down a PG Bouncer with a not that high number of SSL connections. So you can basically be swamped by this. Also, turning off on SSL or rotating the certificates in Postgres requires a database restart, which leads to downtime. So is there any way where we can solve all these problems? So the obvious answer is to offload SSL to Envoy, right? We have already in place the filter. We have Start TLS support, so we can do that. And this obviously avoids the performance problems that I just mentioned from Postgres and PG Bouncer, but it also enhances our observability monitoring capabilities because now we're able to also get the same metrics that Fabrízio was just pointing out before, but for the encrypted traffic too. Otherwise, we would just pass it through. So that's quite interesting. But even more important is that we can leverage here the management capabilities that Envoy has. Envoy allows for dynamic configuration via APIs. And so we can turn this configuration on, SSL on or off, rotate the certificates without any database impact, without downtime, and we can even do that programmatically via the API. So this is coming to Postgres 1.18, Envoy 1.18. Now, the resulting architecture is just an extension of the architecture we have shown before, where there's another filter change, as Fabrízio mentioned in Envoy, the filters can be chained. So here we'll have a change with the Start TLS extension, which will decrypt the protocol, and then all the rest of the flow will be unencrypted to the TCP filter, which emits its own basic metrics, and this Postgres filter, which emits their own very specialized metrics. This is desirable, especially if you're running kind of in a sidecar environment, where the client will connect externally to the Envoy proxy, and then everything else from Envoy to Postgres will happen on Unix domain sockets, where you can obviously be unencrypted.
So the SSL demo is very quickly. Just switch back for the consoles that I showed before. Here I will create a encrypted connection to PostgreSQL. As you can see, the protocol TLS 1.3, the cipher, the bits, compression off, and here on the metrics, we can see now there are a special counter called terminated SSL. It means that this connection was encrypted between client, this client is a PSQL console, and Envoy, but from Envoy to PostgreSQL, it was unencrypted. So in this, using this, we can continue using the ability to expose the metrics to the code, the wire protocol, exposing the metric, even for client connection, encrypted client connections. This is under development. This is a work in progress, issue. We hope we get it merged into Envoy very soon. And this is very simple example of offloading SSL on Envoy.
Okay, that was very cool. And just to close on this presentation, let us just briefly mention one use case and some feature of the Envoy Postgres plugin. So the first one is an open source software we're also developing at Postgres and a wider community called Postgres. You can go on postgres.io and check it out. This is a platform for running Postgres on Kubernetes. And Envoy is used exactly as I mentioned before, is a sidecar to Postgres container. So it transparently proxies the traffic and delivers all these metrics that Fabrízio just mentioned. They are exported to custom Grafana dashboards that are shown in a web console that also comes included with this open source software. And basically this means that there's zero configuration, nothing to do on the database, no impact, no configuration from the user. We're providing very rich metrics from Postgres behavior gathered from the protocol. And looking at a glimpse into the future of what is going to come into Envoy in the future versions, on the next slide, we might see that there's certain cases, certain functionalities that are coming. First of all, the parser, the SQL parser is included right now, is going to be improved. It's not able to parse 100% of the statement, so we're going to get better parsing to also expose all the metrics and, as Fabrízio mentioned, to feed the RBAC, potentially filter, to make more specific, more granular statistics on a per database, because Postgres basically supports multiple databases within the same server, so we can provide per database statistics. In the future, we might add some really advanced functionality, like, for example, query routing, and this could be based on the inspection of the queries that we're doing. This will all happen, again, totally transparent to the Postgres database servers. We can create sharding or routing or read-write, read-only alternatives at the proxy layer. An operation that I'm quite interested in, which is traffic draining, so we can enable this to switch backends to perform failovers and other operations. And finally, the open telemetry integration. This is also very interesting for us for standardizing all these metrics. So basically, if you just want to check what's going on, join the community. Here you have the specifics about the Slack channel, related issues, and there's also some references that are provided here in the slides for you. And that's basically all. We're happy to take on any questions, and I hope you will enjoy and use the Postgres filter for Envoy. Thank you very much.
Thank you, guys.
Okay, thanks for this presentation. It's quite an interesting tool and very unusual approach to monitoring. I have to test it. I'll send some feedback once I've tested. What are the future plans in the development of this tool?
Yeah, thank you for the question. Just let me say just before this that unfortunately my colleague Fabrízio is not able to also be here today with me to answer some questions. He got a bit sick, COVID, but he's doing fine. So he's sending everybody his apologies for not being here today, not being able to answer the questions, actually to also make this session live. But all that said, I'm here to also answer any questions. And regarding yours, it's actually a quite open project and open future also. First of all, Envoy is an open source project hosted or sponsored by under the umbrella of the CNCF, Cloud Native Computing Foundation. And anyone can join, participate, send patches, the same that we just started one day. And Fabrízio and I came to one of the creators actually of Envoy, Matt, and said, Matt, we want to support Postgres. And we started talking. So anyone could join. So we don't know exactly what the future is going to look like because anyone may join or improve the process. But we're interested in several areas. I am myself interested, for example, in something where it's been discussed right now on the Slack channel before creating an issue on how to support offloading the HBA, the host-based authentication mechanism that Postgres has, is something that we can also offload to Envoy. Envoy already has a mechanism to reject connections based on some metadata, which is called RBAC, but this RBAC filter right now may reject a connection abruptly, which is not the what you may expect from a Postgres connection if you were connecting to real Postgres. But it's interesting if we are able to offload this host-based authentication mechanism, because if there is, for example, a kind of an attack on Postgres, kind of a denial of service attack from an application, we will be able to stop this attack at the Envoy layer without hitting the performance of Postgres. And also, it might become a more flexible mechanism. You may be able to filter connections based not only on static IPs or CIDR blocks and users and databases and authentication mechanisms, which is all the capabilities that Postgres HBA supports, but maybe also we may be able to use constructs more usual on cloud native systems, Kubernetes systems, for example, like pod names or service names. So instead of saying, I will allow connections coming from 10.0.0/16, for example, you may say, I want to just allow connections coming from service Jira, for example, if you're running a Jira service, right? And this kind of constructs may be leveraged by doing them on the Envoy filter. So this is one of the options that I envision, well, actually not envision because it's already being discussed, the support of loading HBA authentication to Envoy. But there's many more options. There's definitely the option, right now, the Envoy has a SQL parser, and it's not very much used because actually the parser is not very good. It's not that it was not incorporated as it would work, but rather that it was a parser reused from MySQL filter, and it's not 100% appropriate for Postgres. It's not able to parse all the SQL that comes with Postgres. So it's actually not really advertised, not really used. But if replaced by a proper SQL parser for Postgres, then we may be able to emit a lot of metadata from the queries and do a lot of stuff like query-specific logging, creating something equivalent to pgstat statements, but without even ever hitting Postgres, without having to load an extension to restart Postgres, to use memory, to use performance in Postgres. It's absolutely external tool. To implement query tracing is something we're also considering. There's really many options.
Query optimizing, for example.
Yeah. Even data masking, for example, right? At the end of the day, this is just a proxy, is a front end that controls the traffic, is a gatekeeper. And you can do anything you want. And one of the options is this, okay, I'm not going to return these columns because you're not authorized for this.
We've got a question from the chat. They ask, Maxim Petrovich Karezin is asking, are you planning to add load balancing, including balancing on reading queries? But, well, it was said that there is.
This is one of the most requested topics, but one of the hardest ones to actually achieve. There was several issues created on the Envoy project before we started doing this work that had this as a goal, as an end goal, to create query load balancing. But that effort was basically either non-started or abandoned. And the main reason is that it's a hard one to do, because it's not easy to know, even from the SQL query itself, whether that's going to be a read-write or read-only query. Normal queries may be easy. If you see a select, it's very likely going to be a read-only query. If you don't see an insert or update or delete or DML statement, that's going to be a read-write query. However, you know that you may create any function. This function may actually write data, and then you're going to call the function with select, which means that select is not enough. So you actually need to understand the catalog. You need to even parse the queries. So different query load balancers perform this differently. They support some specific SQL comment as part of the statement that will do the load balancing, or create a load list or reject lists. There's several options. This needs to be discussed. But it could be done, again, for the same reason that I just mentioned before. If there's going to be an appropriate SQL parser that is going to be capable of understanding the whole SQL, as complex as it may get. And then probably the best option is actually support user comments, so that if there's a comment injected saying, send to a read-write node, it will be sent to a read-write node. Is it be sent to a read-only node? Sent to a read-only node. In this case, also, you don't need such an advanced SQL parser anyway. It could be done. Maybe before doing that, because query load balancing is as good as it gets when you can also do failovers, or you can do dynamic reconfiguration. In this case, other functionalities may also need to come before that, like, for example, pausing, being able to say, pause the traffic, just keep it there, keep it coming. It will be enqueued at the Envoy layer, and then release it. And you apply reconfiguration in the meantime, and you release it to different backends. And also potentially connection pooling. It's something that could also be done at the Envoy layer, and it requires a nice amount of work. So it's not something that is going to happen in the next weeks, but it could be done. And they're all more or less related. Not strictly, the query load balancing requires this, but it very likely will be bundled together.
Okay, thank you. What resources do we need to run Envoy proxy and that PostgreSQL filter?
Not a lot. And Envoy proxy is quite performant in general. It's designed for high performance and is used in very high performance environments. Even though it's mostly used for HTTP proxying, it's mostly known for HTTP proxying. Proxying is also used for TCP proxying in general. The Postgres filter doesn't have a significant impact in performance. It has a little bit more if you use this query parser that I mentioned, but it's not very practical in general. So if you're just using Envoy proxy for what is being done today, for just decoding metadata and sending these extra metrics to Prometheus, I would say it's hard to notice the performance hit. And so in terms of latency and throughput, it's not something you can see. The same applies to SSL. SSL has some performance impact by itself, but it's not it's not quite significant. And anyway, you're shifting this performance load to Envoy, and you can relieve Postgres from this. If it's running on a separate box, it's quite obvious the benefit. Now, Envoy itself is multi-threaded, which means that it can use multiple processes. How many do you need? Well, it will depend, obviously, on your traffic patterns, right? But I would say that with a few cores, I may not recommend just running on a single core. You probably do better running on 2 or 4. But that would allow already to process a significant amount of traffic. Maybe on a highly traffic site, you may need maybe up to 8 or even 16 cores. But that will really be able to handle a lot of real traffic. And in terms of memory, it's not something like really memory hungry, a few gigabytes of RAM, which is not a big deal anyway today. Probably will work with less, but RAM is not that much expensive anymore.
Sounds really good. What else application can be proxed by Envoy? Just a side question.
Applications in general. Well, Envoy right now is mostly used for HTTP and supports HTTP1, HTTP2, supports gRPC, and has a lot of extensions and filters, excuse me, to support HTTP proxying. This is where it's used the most. But there's been a specific support for several other protocols as part of Envoy. Including, there's right now, speaking of TCP protocols, there's support for MySQL, there's support for MongoDB, and then there's some specifics for other protocols, and then other extensions not related to protocols themselves, but to enhance the functionality of Envoy. It's quite flexible.
Mm-hmm. Mm-hmm. So
in general, I would say, that is quite an open field. I would like to hear from users, from developers, what could be next. What can we do for Postgres with Envoy? And I would really encourage you all that are watching this talk to give it a try and consider deploying Envoy as a front end to your Postgres databases. Even though you may consider that just some extra monitoring right now, or SSL offloading. Well, SSL offloading is already a big thing, right? Some extra monitoring is interesting, but I think, or actually definitely my vision is to turn Envoy into basically what should be the front end to Postgres. As long as we have an Envoy in front of Postgres with enhanced functionality coming with each release, we're going to be offloading more and more functionality from Postgres, letting Postgres, which is potentially the scaling bottleneck of an architecture, be less that of a bottleneck, because we're going to offload monitoring, we're going to offload SSL connection, we're going to offload the authentication, the host-based authentication, we're going to maybe offload query performance analysis in the future. We're implementing this query tracing. We may offload, who knows, even connection pooling right now in the future, or this query load balancing. And maybe data masking. Like a lot of tools are going to come, or a lot of functionality is going to be coming to the Envoy proxy in the future. So if you start with it now, consider integrating into your architecture as of today, and start testing it. You'll have already the foundations, the base for future work that will implement all these functionalities. And of course, feel free to ping me, Fabrízio, my colleague, or anyone for that matter on the Envoy Slack channel where most of the conversations happen, about what would you like to see as the Postgres filter in Envoy.
I see. I'm going to give it a try. The most part I liked is the monitoring feature, as I said already, and I'm really going to give it a try. That's for sure.
Excellent.
I'll send you my feedback. I'm ran out of questions. We have a special chat here. It's sort of ability of personal talking like we have in offline conferences. Do you have a link?
Yeah, absolutely I do. Yeah.
So let's move there and finish our talk here right now.
Okay, excellent.
Thank you very much.
Thank you, indeed.